Phil Dixon from Shopzilla. Phil, can you come up? Excellent. Thank you. And I just want to say that I know that I've seen Phil's deck, and he's about to present real data. It is incredibly awesome that we have had so many speakers who are showing real data and the impacts of performance and operational improvement on the bottom line. So thank you for doing that.
You bet. So hi, I'm Phil Dixon. Thanks to Jesse, thanks to the Velocity folks for spotting our story and having us come out and talk today. I'll spend the next 20 minutes or so talking us through the process we went through for the site redesign at Shopzilla. I'll tell you a little bit about the background and why we started the process, and then as we talk about what we actually built, we'll overlay that on top of real performance data in terms of speed improvements, and also real performance data in terms of financial improvements and cost savings. So the Shopzilla network is one of the largest and most comprehensive online shopping networks on the web. Through our leading comparison shopping engines, bizrate.com and shopzilla.com, and our Shopzilla publisher network, we serve about 100 million impressions today at a rate of more than about 8,000 searches per second peak. And we do that for about 20 to 30 million unique visitors a month, depending on the season, on an inventory of about 100 million products. Velocity is really important to what we do. The background for why we started this is that in 2000, when our marketplace was first introduced, our comparison shopping marketplace on bizrate.com, the business was really simple. We had a website, bizrate.com, that was relatively simple, a relatively small number of products on the order of millions, not hundreds of millions, only in the US, without a lot of the complexities that come with managing international product with a large and diverse product set. We then, as we grew the business, decided to add on a bunch of co-brands. We built an API to power shopping search for a number of sites out there. In addition, we had co-brands to our own site. And then we decided, with all that complexity, why not also add in a new product, Shopzilla, which is now our namesake, and was intended to be much more in line with a richer shopping experience. So we went from bizrate.com in the US to a bunch of co-brands and API partners to a new product in the US called Shopzilla. Then we added in Europe and a bunch of countries over there for all those brands. We decided that an experimentation framework in the form of multivariate and A/B testing was going to be really, really important to our business. And as you'll see partially today, it certainly was. And on top of all that, right when we got that built, we decided that a single data center wasn't good enough anymore. We had to take an application that was designed for one place and put it in an active-active configuration, and then 2 and now 3 data centers across the world. And it's not like we had time to do this. So with each addition of complexity, we were always in a rush. We had that classic trade-off in the early days of the go-go startup that we needed to gain market share, we needed to get to market. It's not that we didn't ever stop and say the right way to do this is to go down path X. It's that we just never took that path, or rarely took that path. And every time we started to take that path, we very often would take instead the opportunity to get to market faster and just begin to add in this support for the more complex business to our current application stack, which took a monolith that was built for bizrate and made a much, much bigger monolith that supported all of these other applications. The result was the site became really, really difficult to change. Somewhere in 2006, 2007, it got to the point where almost any moderate to large change came with a lot of risk of breaking the site. I think a lot of us have probably lived through that. And as a result, not only did we break the site a lot, we stopped making some of those moderate to large changes without a lot of consideration, because we just weren't willing to break the site, because by then we had too much to lose. So not only were we breaking the site and losing revenue and impacting our consumers negatively, we actually started to slow down the innovation of our product simply because we weren't willing to do some of that stuff. The site had also become really slow. So again, sharing is supposed to be good, but as we all know, when you share too much, it gets to be really bad. So the very same site infrastructure that supported bizrate.com in the US now had to support Shopzilla, now had to support Europe, now had to support all of these other configuration and experimentation framework components. And the result is our website framework, our website slowed to anywhere from 4 to 6, and as you'll see, in the very late days of Site 1, as we call it, we slowed to more like 7 or 8 second page loads, which is clearly just horrible in this day and age. So we decided that it was time to do something about our website. We decided that we had to either refactor the existing framework based on the complexities of the new business, or start from scratch. And in our case, we decided to start from scratch. And the reason for that is our business had just evolved far too much beyond the original intent of the initial code base to actually be in a position to refactor that code base. The second, probably more important point there, is with a business of the size that it was in 2007 when we took this on, we didn't have the flexibility anymore to hold the business hostage for the year and a half it was going to take to rebuild the new site infrastructure. So our choice wasn't to refactor the current site infrastructure. It was to start over on an entirely new stack, which I'll describe in a few seconds. Our design principles were pretty basic. Simple is the new clever. Speed and quality are design decisions. And as the title of this talk suggests, you get what you measure. And it was really the obsession with measurement and designing the ability to measure and test and be fast, if you will, into the website framework that allowed us to get the successes and then show them and measure them later on. We are an agile shop, and I'm not going to make this a process discussion, but we decided in order to maintain the momentum, keep the heartbeat of progress, and generally keep the company connected while we took this big side trip on rebuilding our website, we were going to build the site 2 weeks at a time. So we had 2-week sprints. Always at the end of each one, our mantra was that we need to deploy something somewhere. And more importantly, we decided that we wanted to build the site 1 page at a time. We didn't want to go in a hole and come out a year later with a brand new site. We wanted to build the site 1 page at a time and get our actual user feedback so that we could have the opportunity not to just understand the impact of the new site internally, but also get our users to QA it for us. So we took the approach to manage the risk of our rollout of something that major by managing the exposure. We used our experimentation framework, our A/B testing framework, to show or to incrementally release versions of the site. We used our proxy solution. Our proxy happens to be an A10 solution. We used our proxy solution, our load balancer solution, to allow us to release 1 page of the site on the new site infrastructure at a time while keeping all of the other pages on the old site infrastructure. So what that allowed us to do, since we maintained URL compatibility, is as a user, you didn't really know which version of the site platform you were on. You might have been on site 1, you might have been on site 2, but the reality is it allowed us to incrementally manage our risk, our exposure, get a lot of feedback from the market, see what the real-world interaction with the product would be, and make it better incrementally without exposing the company to a great deal of risk. The first page we released was in December of 2007, after about 3 or 4 months of development. And as you might expect, that first page wasn't as simple as just the page. In fact, it was the first version of the new site framework. We had to stand up the whole thing. We went from a mod Perl monolith to a Java-based stack, which I'll describe in more detail. And then over the months, we started to incrementally increase the amount of traffic we put on the new page initially, and then on the new pages, and then site overall. By March or so, we released the next page. So our marketplace has 3 primary pages. We took the lowest impact page first. We then took the hardest page in terms of complexity second. And over time, all the way through October or so of 2008, we either incrementally released new pages of our Shopzilla site experience, or we released more and more traffic onto it as we got more comfortable. This also helped us with a quality perspective. Because, of course, we had our own quality and we engineered quality in, because, as I said, we're just absolutely passionate about the fact that that's a design time decision. It also allowed us to have a lot of faith in what we actually released being good, actually working. Because all along, first thousands and then tens of thousands and then millions of people had already been exercising the framework. I've heard it called dark launches and all sorts of things. In our case, it was sort of a side-by-side and was critical to our success. So it took us about a year and a half to fully release Shopzilla.com. And it's important to talk about this because one of the aspects of velocity and performance improvement that I want to talk about today is not just financial performance, but it's the impact on our ability to release products. So it took us about 1.5 years to release Shopzilla.com. As you can see on the timeline there, from July to mid-November, it took us about 4.5 months then to release BizRate.com, which was a similar site but required some additional functionality. We'll talk about this a little bit later, but as we have continued our rollout now into our European properties, it took 1.5 years for Shopzilla, it took 4.5 months for BizRate in the US, it took 3 months for BizRate in the UK, and it's now taking 1 month each for each of the remaining sites in Europe. So as we've built up this asset base and built up this site infrastructure, and as we're super confident now in it because it's been running our business for a while, we're able to just innovate and release and roll new products very, very quickly. That timeline will come back as we talk about some of our performance gains. Real quick, to talk about our old infrastructure, it was a very, very, very thick web application. It was a monolith. The very same code that was responsible for showing the text on the homepage counted our money, which meant every time we changed the spelling on the homepage, we can and sometimes did affect our ability to count money. The website talked to the database and our search engine in a very thick way, lot of error states, and as we went from a single homed location to a multi-data center active-active configuration, because we didn't design that in, we added it on, it made our application super sensitive to environmental changes, which frankly had a lot to do with some of our stability and uptime issues. It transformed into what is more or less, I suppose, considered to be a modern architecture. The architecture itself is Java-based, with the exception of our search engine, which remains a C stack. It's service-oriented, lightweight Java services that are marshaled up, and the content from which are marshaled up and delivered through a very thin now web application. We've introduced Oracle's coherence grid as a key part of our infrastructure for caching. A lot about memcached, similar application. And we also made a few other design decisions that any access to a data source where we couldn't control the model would go through a separate service, no longer through the website itself, which isolated the website from changes in external APIs from our ad partners, for example, from data model changes in our database, for example, and many other things. So without talking too much about the high-level stack, I want to start to move the talk more into performance gains and how we got some of them. The page up there on the left is just a simple search for digital cameras on our site. That page is composed of somewhere on the order of about 30 service requests, maybe a little bit more than 30 service requests. When we designed our website framework, we realized and recognized that if we actually wanted a fast site, we had to start there. We had to decide what the absolute limit was going to be in terms of the amount of time we were going to allow our users to wait for the site to load and work backwards from there. So without accounting for banners in this SLA, we have a 1.5 second full page load SLA. And from the user's perspective, what that means is the page is there in their face and they can interact with it within 1.5 seconds. Obviously, we have a pretty heavy site in terms of images and other components like that. So there was some work to do there. We decided based on some experimentation, in a world where we were going to use a progressive rendering methodology, start streaming to the client just as soon as we had data to stream, that we had about 650 milliseconds on the server side in general before we would begin to adversely impact the full page load time. So we set our server-side SLA at 650 milliseconds. And so for us, that means in order to render that page and go out and get data from all those 30 or so services and all those data sources, we had no more than 650 milliseconds to do it. And there is a little bit of serial part of that request. So we make all those service requests in parallel, and you'll see that in more clear detail on the next page. And there is a little serial portion of the request lifecycle where we have to sessionize, add context, where we inject the control for our experimentation and things like that. So in total, 50 milliseconds SLA in the serial portion of the request, 650 total on the server side, and 1.5 seconds full page load. So on average in production, our server-side page load times, our server-side performance averages just under 200 milliseconds. So this Gantt Y-slow-esque, we call it, graph actually shows our service dependency graph for that digital cameras page. Shows you all the service calls that we make. And you can see at the very top the serial portion of the request, which we just classify as sessionization, and then all of the other service calls that we make roughly in parallel to paint the rest of that page or render the rest of the content for that page. There are a few cases, you can see a couple of steps, there are a few cases where we actually wait for something in an initial service call to make a decision later in the page. But we try to limit that, obviously, because it's very, very important to parallelize those requests in order to meet our server-side SLA. Additionally, if we're going to meet a 650 millisecond SLA for the site on the server side, the services have to also have an SLA, and for us, those SLAs are 250 milliseconds, or 200 milliseconds for the servers. So as we talk about that, I want to really define the anatomy of our SLA, because in order to be truly obsessive about measuring it, you have to know what it means. And you have to set the goal. And in order to measure the goal, you have to really understand the context. It's easy to get 100 milliseconds or 200 milliseconds, one request at a time. A little different at 100 million requests a day. So the first thing is we measure our SLAs to the 95th percentile. A lot of people have talked about this over the last 2 days, but averages just smooth out too many of the peaks and valleys, and it makes it very, very unclear what's actually going on in your ecosystem. We also measure our SLAs, or manage our SLAs to peak loads. And so for us, a peak load is a real day times 100%. So double that to account for our holiday shopping season. And then 50% on top of that to account for any unexpected weird spike that we might have in the ecosystem. So peak loads for us means that we have to hit these SLAs at about 225% of any load we see in a typical day. And the last thing is, those SLAs demand a 0% error rate. So in our performance framework, in our performance testing, when we test and load ourselves all the way up to these load volumes, we actually also aggressively manage and monitor the error rate. We didn't initially have that in our SLAs until one day, just before we were launching Shopzilla, we were going nuts and it was great, and we loaded up our servers. And it got really fast, and we didn't understand why it was getting faster and faster and faster the higher the loads we got. Well, the reason is that our search engine was misconfigured and had fallen over because we misconfigured it, and so it was timing out much, much more quickly than it would have actually given us results. So at that point, we added in the 0% error rate, and we began to very, very aggressively manage that as well. So you'll see in the graph on the right, just as a way to visualize this, the green line is our traditional or our typical internet traffic over the day. There's a few peaks every day. And the red line is our server-side performance baseline, which, as you can see, is right at 200 milliseconds. Doesn't actually really move, regardless of the peaks and valleys in the traffic, and is important and key, and shows, in fact, that in order to meet your SLAs, you have to have the capacity and you have to measure them all the way to peak. So all that talking about server-side performance is great, and in my opinion, and most of our opinion, you have to start with the basics and make sure your server-side infrastructure works in order to make sure your whole ecosystem is performant. That said, in our average request, and I think this is pretty typical, more than 80% of the request time is actually spent in the browser or spent on the page itself. And from our perspective, we have just simply applied all the YSLO guidelines and all of the other guidelines out there, or at least most of them, and got our pages as fast as possible. The typical breakdown of time spent in the browser portion of our page is about 20% of that time is spent setting up our banners. That doesn't actually mean bringing the content in. It just means putting all the holes in the page and setting up the page to support the banners. About 30% on image downloads, and the rest on everything from layout, painting, rendering, and JavaScript downloads and the like. It's important to point out that little things, at least in our ecosystem, make a big, big, big difference. So in January of this year, we decided to run an experiment, an A/B test, on one of the YSLO guidelines. One of the YSLO guidelines suggests that you should serve your images from a non-cookied subdomain, and we wanted to understand exactly what the performance difference or the impact on both our user performance and our site would be. So we set up a test to do just that. We served our control for the test was our normal site, serve our images off of bizrate.com, which had cookies, on average about 1 to 2K. For our product images, of which there's about 20 on the page, so you can do the math. There's anywhere from 20 to 40K of cookies then to upload across all those requests, along with the latency. We set up another test on a non-cookied subdomain, where we simply just went to our CDN, created a non-cookied subdomain. The result was almost a 0.5% increase to our top-line revenue for that little change. No code change, just a configuration change, just serving our images without uploading cookies on every request resulted in almost a 0.5% increase in our top-line performance. That's actually really huge. I don't need to say that, but it's really huge and was somewhat unexpected. We weren't able to directly correlate that at the time because obviously the test was affected by users' bandwidth. But again, we did an estimate that for a typical DSL, based on the typical cookie sizes we might be uploading, we might have saved for that DSL user on the order of 100 to 200 milliseconds. For us, it made a material financial improvement. I want to talk about the aggregate now, though. So I talked about a little tiny thing and how that makes a big difference with the non-cookie domains. I talked about all the server-side changes. Here's what it looked like when we released Shopzilla. Pretty clear, obviously, where we released the site. We went from, this is our web metrics monitoring dashboard. We went from a 7-second page load on average to sub-second. And it just fell right off the table there. The little heartbeats in the middle were us trying to figure out how to manage that ecosystem, but we got it right eventually. Same kind of thing with the bitrate release. Right around November 17th when we released, which is the second third, or the last third of the graph, you can see we fall off the table again. There's also one other interesting thing I want to point out here. I talked a little bit about when you manage your SLAs, you have to manage them all the way to peaks and measure them all the way to peaks. If you look at the graph before the bitrate release, you see that it's slowly declining. If you actually, I don't know if you can see it or not, but if you actually zoom in on the dates there, you'll see that it starts to decline right after we released Shopzilla onto Site 2, which means right after we started to take 30 or 40% of our load off of our Site 1 infrastructure, all of a sudden the site started to get faster. It's just an important way and an interesting way to look at the fact that in today's site environment, regardless of our traffic peaks, we maintain a more or less consistent performance baseline. In the previous environment where we didn't really measure SLAs, obviously, and load actually was an important factor, that every single holiday season, every single peak, we always had to scramble to scale up our ecosystem to deal with the new peaks or whatever it is. Today, we're in a bit of a different situation. This slide is simply to say we really keep a close eye on this stuff. We have somewhere on the order of 300 or 400 points of telemetry, maybe more, coming out of all of our services, unique data points, not just instance points. And we keep track of the ones that are most important. We rank them and order them. We alert on them whenever we can. We use tools ranging from post-log analysis through Splunk, through a new management tool that we're integrating now called Clearstone, which not only helps us manage our grid, but also helps us manage and visualize and alert and trend all of these other metrics, all the way to homegrown graphing and visualization tools. Here's the key. If you take your eye off the ball, and in fact, every time we've taken our eye off the performance ball, each and every time we go backwards. Every time we stop watching it, we double, triple, quadruple our performance. And each and every time, that's a bad thing, and then we have to claw back. So it's important, and we've learned anyway, it's important to not just provide the telemetry, not just measure the telemetry, but be absolutely obsessive about watching it and making sure it's doing what we need to do. We talked a little bit about the money we made in terms of the server side, or in terms of the image non-cookie to cookie subdomains, or cookie to non-cookie subdomains. But did we make any money with that big table drop from 7 seconds to 1 second? Yes. So the blended conversion rate pickup on our site was just about 10%, somewhere between 7 and 12, depending on the particular product or property or brand we're talking about. But overall, about 10% pickup in our conversion rate. Just to be really clear, our revenue formula is simple. Number of sessions in, times the rate at which those things convert to monetization events, times the money we make for every one of those events. So a 10% increase in conversion rate, for us, means a 10% increase in top-line revenue, doing nothing else, which, as you can imagine, drops right to the bottom line. So conversion rate is one thing. How about sessions? That's another part of our revenue mix. Well, one way to visualize how we changed or how we improved our ability to get people into our site has to do with what we believe to be the relationship between performance and abandonment. So many of you will know that Google provides a lot of tools and APIs to help you visualize the number of clicks to your site versus our internal reporting metrics is the number of sessions. Forever, depending on the brand, in this case Bizrate or Shopzilla, that ratio between what they think in terms of clicks and what we think in terms of sessions has been somewhere between 90 and 92, 93%. You can spot the release of Shopzilla there on the graph. You can also spot the release of Bizrate. In both cases, in Bizrate's case, we went from 90 to 96. In Shopzilla's case, we went from 94 to 96. Very, very consistent, very repeatable, very obvious increase in sessions just based on having what we believe is a faster site. The theory being, you're on Google, you click, you have to wait, you're just as likely, or at least more likely, to have clicked on another link while you're waiting for this slow site. Faster site, more sessions in our case. We have one more really interesting example. So it's certainly been talked about in the blog sphere. I think it's pretty widely known that in Google's paid search realm, so in the keyword marketplace, there is performance factors in some way into the relevancy calculations for how they show your paid ads. We didn't know exactly how much, but we were able to measure this with the launch of Bizrate UK. We believe the methodology, obviously nobody knows, but we believe the methodology is something along the lines of we have Google takes a look at your peer group, and then if you're too far outside of your peer group, you begin to get suppressed in terms of relevancy, which actually makes sense. All things being equal, a site that takes 8 seconds is going to be less interesting to the user than a site that is much faster. We launched Bizrate in the UK on May 18th. By May 29th, Google's algorithm had figured out that our site was fast, and we had a 120% increase in our sessions from our SEM traffic. So that's more than double by doing nothing other than having a fast site. It even surprised us. We had no idea. We were that deep in the penalty box. But we're certainly happy to find it out and certainly happy to share it with you guys. Performance, in fact, does come from unexpected places. So we had a definite increase in the conversion rate of our marketplace, 10%. That's top line, falling all the way to the bottom line. Other interesting things. With a faster site, you have more dwell time. Even in our marketplace kind of environment, our page views went up by 25%. We talked about the session increases. There's some other also very interesting ways to think about performance improvement in terms of financials on the back end. It takes us less than half of our previous infrastructure in order to support these new SLAs. Our availability went from 99.7% to 99.94%. That's simply taking user sessions that we used to drop on the floor and not dropping them anymore. Obviously, that goes right to the bottom line. Our release velocity went up by more than 2 or 3 times. That's in terms of our willingness to make change, so opportunity cost, and our actual release velocity. So is performance worth the expense? In our case, yes. Right, we've showed you a lot of different ways. There are a lot of other ways that we can talk about, and we will talk about. We've decided to launch a blog to talk about some of this stuff. When you decide to embark on something like this, the key decision is whether to refactor or rebuild. We decided to rebuild just because of where we are. Simplicity, quality, speed, these are all design time decisions. It's hard to retrofit this stuff. It's very, very important to build it in. As we've talked about in the case of the Google SLA penalty, performance gains can be unexpected, and most importantly, you absolutely have to be obsessive about what you measure, because if you're not, you might not get it. So we have lots more to come. We're going to be working on personal search relevancy. We're going to be working on complex event processing. Lots of fun things going on at Shopzilla. Thanks for your time. Thanks, Steve, for having us. Thank you all.